Okay, so today's video Edpuzzle, I want to talk about one thing that we didn't have a chance to talk about today in class, and then I want to do a little review. This is going to be really helpful for your quiz tomorrow. So this will be a great way for you to kind of practice. Remember, you can pause this and try some of the problems yourself and then start it back up. So those are totally your options. Okay, so number one, the one thing that we didn't get to talk about today was perpendicular lines. Make sure you're taking notes. Okay, so perpendicular lines are lines that form right angles. So if two lines are perpendicular, and this is the symbol, it's like an upside down capital T for perpendicular. If two lines are perpendicular, then they form right angles. Okay, so here we go. So here's my example. Here are my two lines. And if they're perpendicular, they form right angles. So let's look at that. Let's just say that one of those angles is right. And I'm going to number them 1, 2, 3, and 4. So from what we learned yesterday, 1 and 2 are a linear pair, which means they would be supplementary. So think about this. If 1 is a right angle, which means it's 90 degrees, and these are a linear pair, then that means they have to add up to 180, which means guess what? 2 would have to be 90 as well, because that's the only thing that would add up to 180. So now 2 would be a right angle. And then 1 and 3, what type of pair are 1 and 3? They're vertical. So they're congruent by vertical angle theorem. So that would mean angle 3 is 90, and then I could do the same thing with 4. So basically, if one of them is a right angle, all the other angles where they meet end up being right angles. So that's pretty cool. So when you show that lines are perpendicular, you only have to show that one of them is right, and it's assumed that every single other angle there is right. So this is the definition of perpendicular lines. That's really important because you're going to use this in terms of like, when we say like which postulate or theorem or definition is, this is definition of perpendicular lines. Okay, so now this is different from definition of a right angle. So let's clear that up. What is the definition of a right angle? If an angle is right, then the measure is 90 degrees. Oops. So usually we say something, instead of, actually I'm going to fix this, instead of just saying if an angle, we usually say like what the angle is. So we would say like if angle, oops, if angle 2 is a right angle, then the measure is 90. That's the definition of a right angle. See how that's different from perpendicular. Right angles say if it's a right angle, then it's 90. Or you could go the other way. You could say, oh, I know it's 90 degrees, so it's a right angle. But it only says right angle, therefore 90 degrees, or backwards, right? Perpendicular lines say the lines are perpendicular, therefore they form right angles. So again, perpendicular, so therefore they form right angles. Those are two different things that are happening, okay? Okay, so let's kind of look at this in action. Okay, so this should look really familiar. This is actually what I asked you to do tonight, so if you're watching this video, this would be a big help to that. This is asking you to tell basically which postulate or theorem or definition applies, and I added some of the ones on perpendicular lines. So again, if it's this, it would be definition of perpendicular lines, and if it's the one talking about an angle being 90, it would be definition of a right angle. So those two are added. So let's take a look. Okay, number one, AD plus DB equals AB. AD is a segment plus DB gives you the whole thing. What's that called when you're adding segments and setting it equal to the whole thing? Segment addition postulate. This is also a good review at the same time. All right, let's try this one. Measure of angle 1 plus measure of angle 2 equals CDB. I'm adding two angles up to the whole thing. Yep, hopefully you said angle addition postulate. All right, how do I know that angle 2 and angle 6 are congruent? Angle 2 and angle 6 is one of the ones we talked about yesterday. They're what type of angles, 2 and 6? They're opposite from each other, if you will. They're vertical angles. So remember, when you say that though, being a vertical angle doesn't make you congruent. The theorem does. So you have to say that. If you want to say that two angles are equal because they're vertical, you have to say vertical angle theorem. Okay, here's a good review. If D is the midpoint, then AD equals half. Okay, first of all, it's a midpoint, and this is the result. So is it definition of a midpoint or midpoint theorem? Hopefully you said theorem. All right, number 5. Number 5 says ray DF bisects angle CBD. So this angle, this ray bisects that angle. So we know we're dealing with angle bisectors. Then that means 1 and 2 are congruent, they're saying. Is that, we know it's an angle bisector, is it the definition or the theorem? Well, because I'm saying the two parts are equal, it should be definition of angle bisector. Okay, 6 says ADF plus FDB. Let's find them. ADF is that angle, plus FDB is that guy. Notice I'm using a different arc. It says that adds up to 180. The only way to know, we know to make angles add up to 180 without saying supplementary is that they form a what type of pair? LPP. Okay, here's a new one. If CD is perpendicular to AB, so let me find those two lines. If CD, this line, is perpendicular to AB, then CDB is a right angle. Perpendicular forms a right angle. It's either definition of perpendicular lines or right angle. Well, let's see. If it's saying the lines are perpendicular so they form right angles, it should be definition of perpendicular. If it says the angle's right, so it's 90 degrees, that's right angles. Let's look. It doesn't say anything about being 90. It says perpendicular gives me a right angle. That's definition of perpendicular lines. Okay, let's keep going. If angle 4 and 3 are congruent, then DG bisects that angle. So you know you're dealing with an angle bisector. And it says the angles on either side are congruent. That should be definition of angle bisector. 9 is a definition. It says if measure of angle 3 and 4 add up to 90, then they're complementary. Guess what that is? Definition of complementary angles. It's that easy, guys. They literally say they're complementary, so they're 90. If you see that, you know it's definition of complementary angles. You should be able to get 10. So 10 says ADF and angle 4 are supplements, so therefore they add up to 180. It's a lot like 9, but it's definition of supplementary angles. Because it said, oh, I know they're supplementary, which means they have to add up to 180. It's different from linear pair. Linear pair says nothing about them being supplementary. It actually has in the figure, you can see that they add up to a straight line. That's why that works. Oh, I don't want to do 12, so we can get rid of 12. But I do want to do 13. 13 says, if FDG is a right angle, then FDG equals 90. Aha. Finally, I'm saying right angle gives me 90 degrees. That's the one that's definition of a right angle. So look at the difference. Here's the difference between the two I just talked about. 7 and 13. 7 told me that it was perpendicular, so they made right angles. So we're dealing with perpendicularity giving me right angles. That's definition of perpendicular lines. If I'm talking about right angles and being 90, that's definition of a right angle. And you're going to have to know the difference between them tomorrow, so you're going to want to make sure that you do. Okay. Okay. So let's do some review of some of the older postulates with theorems, and we're going to do these as always, sometimes, or never. And this is a little different. So if it's always, that would mean that it's always going to be true. If you know that it can't happen, absolutely not, that's never. Sometimes, the way I do sometimes is I ask myself, like, can I think of a way that it could be true? And can I think of a way that it's not true? And if they both exist, then I'm going to say sometimes. So let's see. If given 3 random points, they are when collinear. Remember, collinear means they're on the same line. So imagine I just put 3 random points on my paper. Could they be collinear? Sure, maybe I drew them in order. But could they have not been collinear? Sure. So that would be sometimes. We'll just do A, S, and N. Okay, 3 points define a unique plane. 3 points. So they're saying if they give you 3 points, that's going to be exactly one plane. Well, I'm just going to tell you what, they're missing a very crucial word. They didn't say non-collinear. And because they didn't say non-collinear, this isn't always going to make just one. Remember, sometimes if I have 3 points, I can draw like the plane that goes vertically if they're collinear, and then I could maybe draw the plane that goes like this. So if my points are all on the same line, I can actually draw tons of planes that go between them. It's like kind of like being on the corner of a room or the spine of a book. So if they just say 3 points and they don't say non-collinear, this is only sometimes, because maybe it is, but maybe it's not. All right, 2 lines. Do they always intersect? Do 2 lines always have to intersect? Do they never intersect? Or can they maybe and not? Well, let's see. Could lines intersect? Yes, lines could absolutely intersect. Do they have to? No, I can have 2 lines that don't intersect. We're going to talk about those soon. They're called parallel. So if you can and cannot, then you're sometimes. Okay, 2 intersecting lines form a unique plane. Let's see. 2 lines. This is a definition from before. We said if we have 2 lines that intersect, yep, they always only form one plane. So this is always. If they intersect, if you have intersecting lines, they're going to form a unique plane. All right, if you're given 3 points, they define exactly one plane. Aha, this is a trick. It's the same as question 2. If you're given 3 points, they sometimes define exactly one plane. I should have thrown the words non-collinear in there. That would make it more fun. All right, let's try another one. If 2 planes intersect, their intersection is a point. If 2 planes intersect, like the corner of a room, right? Here's your room. They intersect to form, it is not a point. Their overlap is a line. So this one would be never. It's never just a point. If 2 lines intersect, their intersection is a point. What do you guys think? If 2 lines intersect, yeah, they only intersect to form a point. So that's always. If 2 angles are supplementary, then they are a linear pair. Ooh, that's tricky. If 2 angles are supplementary, they form a linear pair. Well, if you guys remember, I said supplementary and complementary angles don't actually have to be next to each other to add up to 180. They just have to add up to 180. So they don't have to be a linear pair. They could be, but they don't have to be. So that would be a sometimes. If 2 lines intersect, then exactly one plane contains them. That's this guy again. That is an always. And when given a line and a point not on it, they are not coplanar. Well, let's see. We remember how we said that we have 2 points on the line at least, and we have this extra point out here. If you have 3 points and they're non-collinear, they're always coplanar, guys. So that one would be, it says they're not coplanar, so that would have to be a never. I would go through those a couple of times. I'm definitely going to put a little section of always, sometimes, or never, and you're going to want to know them. So practice that a couple of times. All right, last stuff that I want to do is just kind of go over some general ideas. So I'm going to put symmetric property, I'm going to put reflexive property on the quiz tomorrow, so you're going to need to know all those. Angle addition, segment addition, addition property, reflexive property. It's going to be a matching, so you're going to want to review all those properties, of course. But then you're going to want to make sure that you review things like vertical angles, linear pairs, and supplementary and complementary. So I'll do that here. So here's an example. Like maybe I give you the angles and I label them, 2, 3, 4, 1. And I tell you the measure of angle 1 is 5x plus 10. Maybe angle 2 is 3x minus 40. okay? The first thing that I would do is label my shape, and some of you guys are really good at this, and some of you need a little more work. So maybe this is 5x plus 10 there, and then angle 2 is 3x minus 40. Okay, so the first thing I would ask myself is, well, actually, let me give you a question first. So I want to know what x is, and then I want the measure of angles 3 and 4. Okay, so we'll do both of those things. Okay, so the first thing I would do is ask myself, what's the relationship between these two given angles? So 1 and 2 are not vertical. 1 and 3 would be vertical, and 2 and 4 are vertical. But 1 and 2 form a straight line altogether, so they're a linear pair. So they should add up to what? 180. That's right. So I would add them up, set them equal to 180. Add 30, so I get 210 equals 8x. I would divide both sides by 8. And I don't get the nicest number, but that's okay. I get 26.25 degrees, or whatever. It doesn't actually matter for that one. So that's what x is. Okay, so now I need the measure of angle 3. 3 is here, right? I don't have anything marked for 3, but I know that 3 is vertical to 1. So whatever 1 is going to be, 3 is going to be the same. So we could figure out what angle 3 is now that we know x. I'm going to sneak in 26.25 there. So I'm going to take 26, and I can use my calculator, that's fine. 26.25 times 5, so I get 131.25 plus 10. So I get 141.25 for angle 3 degrees. Make sure if you're giving me the measure of the angle, you're using the little degree symbol. All right, angle 4 we don't have marked, but we know it's the same as 2. So I'm going to use 3x minus 40 to solve for that. So I'm going to plug in my x value, and then I'm going to grab my calculator and take 3 times 26.25, which is 78.75, and minus 40. So I get 38.75. On the quiz, I'll probably make them a little nicer so they're not quite such nasty decimals, but you could have them, so that's good to know. Okay, so in that case, I ended up having to use the supplementary relationship, right? Okay, let's do another one. How about this guy? Again, if you want to pause and try them yourself, you can. So let's do this one, and let's say I'll use 5, 6, 7, 8. Okay, so maybe this time I give you the measure of angle 6 is equal to 10x plus 12, and maybe the measure of 8 is 5x plus 42. Okay, so first things first, I would label my shape. I would label my diagram, excuse me. This whole thing is 10x plus 12, and this whole thing is 5x plus 42. Okay, so what do I know about 6 and 8? Is there a relationship between them? Yeah, 6 and 8 are vertical, so by vertical angle theorem, I know that 6 should be the same as 8, so I can set those two expressions equal. So I get 5x equals 30, so x is 6. And let's say not only do I want x, that'll be one thing I asked for, but then maybe I want the measure of angle 6 and I want the measure of angle 5, okay? Because I like to ask extra stuff. So now that I know that x is 6, how can I get angle 6? Well, I'm going to plug in for x, right? So instead of the x, I'm going to have 6. So I get 60 plus 12, or 72. Okay. And then I need to get 5. Now this is where it can get kind of tricky, because you don't have an expression for 5 or 7, even though they're the same. So what I would do is use this, guys. If you have a straight line, you've got a linear pair. So now that you know that 6 is 72, you can figure out 5, because you know that 5 and 6 have to add up to 180. So you could say 72 plus the measure of angle 5 has to add up to 180. And you do need to show me your work. So the measure of angle 5 would be 108. Okay. And this picture doesn't have to be to scale, so it's fine that this one is actually obtuse and that one's acute. That's fine. Okay. And then let's do one more, and then I'll let you go for the day. So the last type that I might give you is something about maybe complementary and supplementary angles. So maybe I tell you, we'll do two questions. So maybe I'll tell you two angles, angle F and angle G are complementary. Measure of angle F equals 6x plus 8, and the measure of angle G equals 4x minus 3. Okay? Okay. So you have to figure out, you don't necessarily have to do a diagram, but a sketch could be super helpful. It's up to you. Okay, let's say that I want x and I want the measure of both angles. So I want F and I want G. Okay. Well, what I know, if they're complementary, I know they add up to what? 90. Or you could also think of it as like they form a right angle. So I could kind of think of it as, okay, these two things are going to create a right angle. One of them is 6x plus 8. The other one is 4x minus 3. You don't have to do a diagram. Some people can just go right to the equation. That's fine too. So I know these two things, 6x plus 8 and 4x minus 3, have to add up to 90. All right, so let's solve this thing. 10x plus 5 equals 90. I would subtract 5 from both sides, so I get x equals 8.5. Not terrible. Now, if I want to get f and I want to get g, same thing as always. I'm going to take f and I'm going to replace it with the x value that we found. And again, you're welcome to use a calculator as you're doing this, and you can use one on the quiz. So I get 59. And for g, I'm going to do 4 times 8.5 minus 3. And I got 30. And you can check to see if you're right, because these two angles, remember, they should still add up to 90. And they do. Okay. So then the same thing could be true for supplementary. So maybe I might say, you know, angle H and angle J are supplementary. If angle H is equal to 2x minus 10 and angle J is equal to 3x plus 30, find x, the measure of H, and the measure of J. Okay. So same thing. The first thing I would do is go, oh, they're supplementary. That means they equal what? 180. And then basically you can just add these guys up to 180. So again, you can do a picture, but you don't have to. 2x minus 10, oops, plus 3x plus 30 equals 180. So then I have 5x plus 20 equals 180. 160 equals 5x. Then I would just divide both sides by 5. And so I think I end up with 32, but I'm just going to check my math. Yep, 32. So there's x, but then don't forget, they want the measure of angle h, so you should show that. So I'm going to get h by doing 2 times, instead of x, I'll put a 32 in, minus 10, so I'm just going to go back up here. So that gives me 64 minus 10, or 54. And then j, which is 3 times 32 plus 30, so I'm just plugging in the x. So I get 96 plus 30, which is 126. So make sure you label what you're solving for. So just to double check, I could add these two together and make sure that I do get 180, and I do. If you got something different, then maybe there was something that had went wrong along the way. Okay. So again, tomorrow we'll review a little bit before you take your quiz. We'll talk a little bit about, you know, those properties again and just make sure everybody's comfortable with that. And then we'll get started on the quiz. So make sure you review this and that you feel comfortable with vertical angles being equal and supplementary and complementary and linear pairs and all that good stuff. Okay? All right, I'll see you guys tomorrow. Have a good day.